Tutorial 5. When a hydrometer in figure 11 having a stem diameter of 1 cm is placed in water, the stem protrudes 80 cm above the water surface. If the water is replaced with a liquid having a specific gravity of 1.10, how much of the stem would protrude above the liquid surface? The hydrometer weighs 20 grams. So this is hydrometer. So it's look like this. So and then normally we will put a way here to balance the usage of the hydrometer. So in this question, so if we put this hydrometer in water, so the height here is 80 centimeter. So however, when we change the liquid, so we put this hydrometer in a liquid which has a specific gravity of 1.1, so we need to calculate what is the protrusion length here, whether it is increased or decreased. So first we need to calculate the condition of water. So we could draw the free body diagrams. We could say that the force of buoyancy is equal to the weight. So and then the weight here is mg, so we know that it is 20 grams times the gravity, and then we calculate the force of buoyancy by using the rho gv. So we know the rho of water and gravity, and then we could calculate the volume of the displaced area. So the volume here, the displaced water, is 2 times 10 to the power of minus 5 meter cube. So and then we take that hydrometer and we put in a new liquid. So again the distribution of force is remain the same. Force of buoyancy is equal to the weight, and then the weight of the hydrometer is remain the same, but the rho gv is different because new liquid has specific gravity of 1.1, and then we could calculate the displaced volume here, which is equal to 1.82 times 10 to the power of minus 5 meter cube. So here we could compare the volume. So we found that the volume for water is more compared to the volume of new liquid. So means that the volume difference here is, so we get the volume of water minus with the volume with new liquid. So it is equal to 1.8 times 10 to the power of minus 6 meter cube, the difference of the volume. So what we need to think about this is, so for example, for water here, so it will stay like this one. So means that the protrusion length here is 80 centimeter. So and then if the volume is reduced, because we deduct the water minus the new liquid, so means that the submerged volume here is lesser compared to the submerged area in liquid in water. So means that the protrusion here is increased. Okay, however, what we get here is the volume. So what is the relationship between volume and height? So we know that this protrusion has 1 centimeter diameter. So according to that data, according to that information, we could calculate the protrusion height. So the idea is difference of volume will change the length of the protruded section. So A times L will get the volume different. So we substitute the value, we could calculate the value of L here. So the L here is the height. So and then because the new liquid has less volume submerged in water, so the hydrometer will float more. The stem would protrude 80.023 centimeter above the new liquid surface. So a hydrometer or lactometer is an instrument used for measuring density or relative density of liquid based on the concept of buoyancy. They are typically calibrated and graduated with one or more scales such as specific gravity. A hydrometer usually consists of a sealed hollow glass tube with a wider bottom portion for buoyancy, a ballast such as a lead or mercury for stability, and a narrow stem with graduation for measuring. The liquid to test is poured into a tall container, often a graduated cylinder, and the hydrometer is gently lowered into the liquid until it floats freely. The point at which the surface of the liquid touches the stem of the hydrometer correlates to relative density. Hydrometer can contain any number of scales along the stem corresponding to properties correlating to density. Hydrometers are calibrated for different uses, such as a lactometer for measuring the density, creaminess of milk, a saccharometer for measuring the density of sugar in a liquid, or an alcoholometer for measuring high level of alcohol in spirits. The hydrometer makes use of Archimedes principle. A solid suspended in a fluid is buoyed by a force equal to the weight of the fluid displaced by the submerged part of the suspended solid. The lower the density of the fluid, the deeper a hydrometer of a given weight sinks. The stem is calibrated to give a numerical readings. So this is the image, the diagram of the hydrometer as explained previously. If we put it into a liquid like this one, if it has a higher density, for example, the higher density, so means that FB is equal to rho G and volume. So the higher density here will give a large amount of force of buoyancy. So large amount of force of buoyancy means it could float this object so much. So means that the protrusion here will become higher. So and then we have a scale here. So and then in this scale we could know the value. So especially in fluid mechanics, the scale here is for specific gravity.